All right, from Algebra 2A, folks, we're looking at the quiz on logarithms version 1, and we'll see how quickly we can get through this here. So our first section, 1 through 5, says we want to write each equation in logarithmic form. And so just to remind you here, this is going to be kind of the rule or the pattern that we're going to use. If we have a raised to the power of b equal to c, then the logarithm base a of c equals b. So kind of the thing to keep in mind is that basically we're going to start with what's called exponential form. We're going to write it with a logarithm. B and c are basically just going to change positions. They're going to switch, and then we're going to apply the logarithm. So that's about all we're doing here. And number 1 right away, you might want to rewrite this. 2 to the power of 3 equals 8. If you want to make it look a little more like the property that we're using. So we'll keep this base of 2. So it'll be the logarithm base 2, and that's technically the 2's written when we apply the logarithm, a little bit lower. But then the 3 and the 8 are just going to change positions. That's it. So log base 2 of 8 equals 3. That's it. We're done. That's how simple it is. If we try number 2, we've got base 7, so we'll have log base 7, and then the negative 2 and the fraction here are going to switch. So log base 7 of 1 over 49 is equal to negative 2, and that's it. We're done. That's all there is to it. Okay, we'll scroll down here if we can. All right, so then for number 3, we have the maybe a little confusing base e, but e is a number, kind of like pi is a number. So we'll have log base e, and then again, the exponent and the other number are going to switch here. So log base e of 148.4 equals 5. Now, the only other thing you might do here is when you have base e, we often call that a natural logarithm. And I'll just abbreviate here, natural log, and we often abbreviate it as ln. So I would probably accept it on a quiz or a test if you said log base e, but I just want you to understand that log base e we just write as ln. So don't even have to write the base, just the ln, that's the natural logarithm. 148.4 equals 5. So that would be, again, I would accept log base e of 148.4 equals 5, but if you want to challenge yourself, it would be the natural logarithm, ln 148.4 equals 5. A couple more in this section. Again, number 4, if you wanted to put the exponent on the left first, if that makes it a little bit easier for you here. But our base is 12, so we'll have the logarithm base 12. And then we're going to switch the a and the 23, and that's basically all we're going to do here. So log base 12 of 23 equals a. And then we got one more here. We'll do this one in red again. So we'll have log base w, and then we're going to switch the 2 and the 58. So log base w of 58 equals 2. And that's it. That's that equation in logarithmic form. Notice for a few of these, like number 3, first of all, e is a variable. Or excuse me, e is not a variable. E is not a variable. E represents a number. E is approximately 2.7 something. I can't remember. But otherwise, number 4, a is a variable, but we don't know the value of a. And we're not asked to figure out the value for a. That'll come in later problems. We'll have something like that, perhaps. Number 5, w is a variable. We don't know the value of w, but we could try to figure it out. Some of you might know, you could just do the square root of w to solve for w, but that's not the point here. We're trying to go from an exponential equation to a logarithmic. So let's scroll down here, and we'll try out going the other way. But let me just rewrite here for us that kind of the rule that we're using. Okay, so again, what we had written up above, if a to the power of b equals c, then we can rearrange this relationship, use a logarithm instead, log base a of c equals b. So we're just going the other way now. We're starting with a logarithmic equation, and we're going to write the equation in exponential form. So for number 6, my base is going to be 5, and then we're going to switch the 125 and the 3. So it's 5 to the 3rd power equals 125. That's it. We're done. That's all there is to it. This one you can verify too, by the way. You can, type in 5 to the third power, do 5 times 5 times 5. You do get 125. This one here, number 7, this is a good one because you say, what's the base? There's no base written down. I don't have a little number written down there. So the thing to remember here is if there's no base written, it's known as a common logarithm or a common log, and the base is 10. So that's just kind of understood here. So if you wanted to fill in a little 10 there. So we can keep the base of 10, but then the 4 and the 10,000, those are just going to switch. So 10 to the 4th power equals 10,000. This is another one if you wanted to, you might rewrite this with the logarithm on the left, just if you wanted to look a little more familiar, if you wanted to look like number 6. But let's keep going here. Natural log, I think we saw that up above, so that's really log base e of 0.3 equals, or is approximately equal to negative 1.2. But e is my base, so e to the power of negative 1.2. We're switching the 0.3 and the negative 1.2. E to the power of negative 1.2 would be approximately, sorry, I didn't put the approximately symbol, but 0.3. And again, with e actually being a number, if you know how to find e on the calculator, you could verify that. You could punch in e to the power of negative 1.2 and see if you get 0.3 or approximately. Number 9, we've got base m, which is a variable. I don't know what the value of m is, and I don't care in this case, but m is my base, and we're going to switch the 18 and the 9. So m to the power of 9 equals 18. We are done. That's it. I could solve that for m if I know how. I would apply a 9th root, but that's not something I'm expecting most folks in Algebra 2 to know. One more for this section here. So again, if you wanted to write the logarithm on the left, not that you have to, but we got a fraction here, and that's okay. Fraction is just a number. So my base is y, and we're going to switch the fraction with the negative 3. So y to the power of negative 3 is equal to 1 over 64, and there's the equation in logarithmic form. We are done. So yeah, so that's just the basics of exponential equations and logarithmic equations and how they're inverse operations or inverse functions of each other. They're related there. So hope that helps you. We'll see you in the next video.